Predicting the future with quantum computing and AI. I am Olympia Lapointe. In this particular presentation, I'm going to show you the power of quantum computing and show you how it relates to today's artificial intelligence. In this talk, I'm going to introduce to you quantum physics by taking you to the past, bringing you to the present, and delivering you to the future. Today, your basic questions about AI and quantum computing will be answered. You will discover something no one else knows. We'll answer basic questions to artificial intelligence like, what are the business benefits to using AI that helps businesses compete? And we'll answer what type of digital theft exists with AI. With quantum computing, we will answer these basic questions. What impact will quantum computing have on security? And what will the technology look like for the future? There is a major opportunity in front of you. I am Olympia Lapointe. My specialty is helping you see into your future with science, my books, and keynote talks. I helped launch 28 NASA Space Shuttle missions into space. And I gave the TED Talk, Reprogramming Your Brain to Overcome Fear. In it, I talk about my experience launching rockets and what it took to be able to launch such wonderful technology. There's a major opportunity in front of you. You are in front of a door of opportunity. Now, it's not just any door. Specifically, it's what I call a portal. It's a portal. You are in front of a door, and it's not just any door. It's a portal. Now, you may be wondering, what is a portal? You and your company are about to go through a portal to a new dimension. What is a portal? I know you may be asking. Well, it's this. A portal allows you to be able to not only walk through a door of opportunity. Once you walk through it, what would have taken you 10 years to do will take you 10 minutes. What would have taken you 6 years to accomplish can be accomplished sometimes in 6 seconds. Both in quantum physics and in scripture, a portal is a doorway to a new dimension. It takes any idea, person, place, investment, relationship, business, or thing and transports it to a new, higher dimension for powerful future life-saving breakthroughs. See, you are at your portal. New decisions about the future will allow you to walk through your door. But there is an opposition that will not want you to go through this door. I hope you do realize this. Going through this door is so powerful, and there is opposing forces that will do anything and everything as you approach that door to stop you from going through it. Because once you go through it, your life will forever change. See, if you want to invest in technology, there's dark forces that will keep you from walking through that door. There are dark forces that do not want you to know about the dangers as well as the opportunities of future technology. So your job is to learn about the future of artificial intelligence and quantum computing for future wise investment options. See, there's a 3-step process to move past this opposition and move towards your door and open the door to new investment opportunities in technology. We will go into the past, we will come into the present, and we will go into the future in this particular portal. And to open that portal is by taking the following steps. The first step is you have to decide to make decisions now by going into the future. Now, I rarely share about my own personal story, and I'm a person of faith. And I was praying the other day to God, and I asked God, what would be a great way to explain this first step? How do I show you how to decide to make decisions now by going into the future? And what I received was tell my own personal story. So, may I share with you my own personal story? I have a feeling you're saying yes. So, I'm going to share with you my own personal story. So, you have a quantum future. You can decide to see into the future and decide to defy the odds. And I did that in my own special life and case. Here I am, Olympia LaPointe, at 6 years old. This picture was taken by my mother, and she took this picture when I was 6 years old. She had a photography class, and she said, "Sit in this rocking chair so I could take a photo of you." And I kept this picture, and it's a picture that reminds me that great things can occur in the future if we envision it. When I was 6 years old, I took a field trip, and I took a field trip to this location, the Jet Propulsion Laboratory in Pasadena, California. And when I went to that particular location, it was amazing. I was 6 years old on a school bus, and the tour guide was showing us planes, showing us jet engines, and she took us to this room. It was the mission control room at JPL. And I fell in love with the room. It was so amazing. There were TV screens everywhere. There were monitors. And it was so amazing because on the wall there were these pictures of these men, and these men were launching rockets. And I looked at the pictures and I said to myself, I want to be just like the men launching rockets. But I had no clue how tough it was going to be as a woman and a woman of color to be able to reach that particular feat, because I didn't necessarily grow up in an environment that supported rocket science work. In fact, after this field trip, I left the Jet Propulsion Laboratory, JPL, and I went back home. And where I went back home to was South Central Los Angeles. Now, this image is not from when I was 6 years old, but rather it was from 1992 after the Los Angeles riots. And it gives you an idea and a visual depiction of the type of chaos I went into when I went home every day on my school bus from being bused into school. Now, although this is an image from 1992, the fact still remains the same. When I was 6 years old, I went back to South Central Los Angeles, and it wasn't easy. I started failing some of my math classes, actually, and I didn't realize the odds that I was up against. I didn't know that 1 in 31,000 African American women or women of color would become a rocket scientist. I didn't know that. I didn't know, exception to the fact that I went to that JPL mission control room and I knew I wanted to launch rockets. You see, I had several different futures in front of me. I could have gone into gang violence. I could have dropped out of high school, or based on my trip to JPL, could become a rocket scientist. Now, each of these futures equally existed in a higher dimension, but it was through my decision making that I chose future 3, which was to become a rocket scientist. You see, we each have futures that are in front of us, but we get a chance to choose the one that we want to go to. And I didn't realize how powerful our free will and decision making is until actually close to 20 years later. It was close to 20 years later that I realized the power of our decision making. You see, when I was 9 years old, just a couple years after that photo was taken, I started doing poorly in mathematics. I started having some issues at home, and whenever there's issues, emotional issues in kids, the first place that you see it is in their math work. And I started doing poorly in my math. And I remember waking up at 3 o'clock in the morning, stressed out because I didn't finish my homework and I still needed to finish my handwriting. We did handwriting exercises back then. And I remember going to the dining room table, picking a sheet of paper and practicing my handwriting. And I remember practicing my handwriting, pretending to write my handwriting messy like a doctor. I made up this name. I wrote Dr. Surgasong on this piece of paper and wrote it in such a messy way. I said, I'm going to become a doctor and write things messy. So that's what I did. And I was so inspired by the DR doctor in front of the name. I said to myself, what if I put doctor in front of my name? And so I then wrote on the piece of paper, Dr. Olympia Lapointe. And then I thought to myself, wow, that's really hard to do. What's the hardest thing I can do in the future? And then on the piece of paper, I wrote Olympia Lapointe, rocket scientist. Now, I didn't realize what I was doing. I was 9 years old and I was sitting at my dining room table, writing on a piece of paper, and I didn't know I was mapping out my future with quantum physics. I didn't realize that. All I know is that at that moment when I wrote Olympia LaPointe rocket scientist on that piece of paper, my mind started going into the future and I started envisioning myself. I saw myself sitting in this room with computer screens and opening up this book that had math equations in it. In fact, the room somewhat looked like this. I went into this room and in my vision, when I was 9 years old, I was sitting at this computer desk. It was in this mission control room. And I remember looking at all the data and the numbers on the screen. And I remember thinking to myself, wow, I made it. I made it. I became a rocket scientist. And then I opened this book next to me. And the book next to me, when I opened it up, had this really long equation in it. And I remember taking note of the equation, thinking to myself, I've never seen this equation before. And I remember sitting here at this desk, just being amazed about how wonderful rocket science was. And then I came out of the vision. I came back to the piece of paper, and I realized by this time it was way into the morning. I probably should get back to sleep. And so I went back to sleep, but I didn't know that I was programming my brain to go into future three, which was rocket scientist. After having that vision of sitting in that mission control room, I later on chose to major in mathematics. After failing a number of my courses, algebra, calculus, geometry, and chemistry, and having to take them over, I met a math teacher that showed me mathematics, and it gave me courage to major in mathematics in college. So I majored in mathematics and I became a math tutor. And this is where I helped thousands of students in group tutoring programs become successful in mathematics. And I helped people graduate with their degrees because they all needed mathematics to graduate. And in doing so, I became one out of the top 5 graduating seniors of a 6,500 graduating class from California State University, Northridge. I took the mathematics and science and I applied it. After graduating, I worked at the Boeing Company where we launched the NASA space shuttle. Now, if you're familiar with the movie Hidden Figures, you'll know the woman to the left is the late Katherine Johnson. Katherine Johnson was a mathematician for NASA, and she did something similar to myself. We did two similar things with mathematics, but she worked on something slightly different. She worked on the mathematics of the trajectory that would allow someone to launch the space shuttle into the trajectory to the International Space Station, where when that would come about, as well as to the moon and beyond if it was needed. 30 years later, I carried on that type of mathematics, but instead I used mathematics and science to calculate the probability of catastrophic explosions within space launches. When I mastered that, I then went to understand all the different areas of this engine. This is a rocket engine of the space shuttle. This is now an exhibit at the California Science Center in Los Angeles. So in this photo is the image of a engine, a rocket engine. It has tubes, it has welds, it has manifolds, it has ducts and lines. My job was to know where every single duct and line was located, every weld, every tube, how the liquid hydrogen and liquid oxygen propelled through the system to create clean air. And I had to interface with the engineers, with the thermodynamics, with the bending moments, with the ISP, with all the different areas of a rocket engine to fully understand how rocket engines work, to describe how to stay safe with advanced engineering. And then after that, I graduated to signing off on the space shuttle engine tests. Now, I was a person who signed off, gave an authorization, gave my signature to test the space shuttle main engine. And in doing so, I had to ensure that the test was going to be safe and there was going to be no human loss of life. So my job was to ensure safety with technology. After I mastered this ability to test the engines and authorize the safe test of these advanced technology products, I graduated to working in and supporting mission control. This room is the ROSC. It was the Rocketdyne Operations Support Center, and we were part of mission control to ensure that the rockets and the space shuttle as a whole reached into its proper orbit safely. Now, I want you to notice something. Here I am as a rocket scientist. Something really fascinating happened when I sat at that desk. Remember when I was 6 years old and then 9 years old, and I had that vision that I was sitting at a desk? Fast forward, here I was, sitting at this desk, and I remember looking around, and as I was looking around, I realized, wait just a second, I've been here before. I've seen these monitors. I've seen this information across the screen. And then I looked to the left of me, and I looked inside the book, and the book to the left of me had the same equation that I had seen before. And I thought to myself, where have I seen this before? Where have I seen this before? And then it came. When I was 9 years old, when I couldn't sleep and I woke up in the middle of the night and I was writing Dr. Circa's song, Dr. Olympia LaPointe, and then Olympia LaPointe, rocket scientist, on that piece of paper, I saw this in advance. I saw the future. And as I sat here in the present moment at this desk, I realized I saw this when I was 9 years old, even the equation that was in the book. And that's when I realized We have the capability to see into the future and pick the future that we want and move towards it through the decisions that we make today. I cannot make this up. This is a real life situation that I experienced. And now I show you how to go into the future and do the same. And that brings us to the second step in understanding advanced technologies. We have to understand the future company's major benefits and major risks posed by new artificial intelligence. So I'm going to take us into the present. The past, step one, took us into the past. I'm going to bring you into the present for you to see how emerging technologies are changing. Artificial intelligence is everywhere. And specifically, generative artificial intelligence is what we see in the news with ChatGPT and OpenAI and Copilot and Gemini. We're going to explore how it operates and the future risks of all generative AI, and we're going to see why generative AI was originally developed, something that no one may have told you. You see, we've been using artificial intelligence for years. It was first theorized in the 1960s, but early as the 1980s, we've been using AI, and the first people who used AI were the baby boomers. If you're a baby boomer, raise your hand. Baby boomers were first using AI with ATM machines. You see, generative AI, the type of artificial intelligence that's out now, is a special type of artificial intelligence that looks at three things. It looks at text, it looks at voice patterns, and it looks at video. And the earliest type of artificial intelligence that we saw was when people went to an ATM and cashed their checks. The machine had to read your writing on a picture, and that type of text was translated into money that you got from the ATM machine. That was the first form of artificial intelligence. Now, if you're in Generation X like myself, you saw artificial intelligence used with cell phones. It was the first time phones, you could take them with you. They weren't just on a wall. You didn't have to be at home waiting for a phone call. You could go anywhere with your phone. And as artificial intelligence progressed, you could go online on your cell phone, and it was in color. The millennials started understanding artificial intelligence with Siri and Alexa. They would ask questions to the artificial intelligence and it would give them answers back. All these particular areas were gearing us towards generative AI, which is Gen Z now experiencing it. Baby boomers were understanding AI in pictures. Generation X was starting to text, and the millennials were feeding the AI with voices. Now, Gen Z is now looking at robotics, which is dealing with generative AI that looks at both images, it looks at text, and it looks at sound and voice command to give instructions and make decisions. But here's the hidden fact that people do not want to reveal, and I'm about to reveal it to you today. Are you ready? Here's the hidden fact. In 2020, generative AI was supposed to be created to do something different than what it's doing right now. Do you know what it was originally created for? In 2020, generative AI was originally created to transform banking and government data from COBOL computer programming to Java. You see, generative AI, which is now used in the videos and synthetic media and creating all these fake images. Well, originally, the reason why generative AI was supposed to exist was because there was COBOL programming in a lot of different systems, and they needed somebody to talk into an AI system to tell the system what the code was supposed to do. They needed a way to put in the text from the COBOL and then look at the engineering diagrams of how these systems operate so the generative AI could transport the COBOL into Java programming. And we're going to look at that in detail. Now, there's a four-step process to create AI. Now, if you're not familiarized with AI, I'm going to show you the four-step process so you get an understanding of it. AI is artificial intelligence that makes decisions based on four steps. First is the data. There's a whole lot of data that exists, whether it be cell phone records or MRI scans or different pictures and images. It's data. And so all of this data goes into a system, but you have to be able to sort through these billions and trillions of lines of text. And so as a result, there's an AI developer that will design an algorithm in step 2 here to help you sort through the data and make decisions based on what the data is telling you. Now, once that AI algorithm is formed and that algorithm then makes a decision based on the data, it's then tested in real life. So this test will, let's say, for example, an algorithm will say, is this image showing a benign tumor or a cancerous tumor? So that test then is tested on maybe 100 or 1,000 different patients to see if it works. And if it does work, then you can deploy it and use it in real life. And this is with any AI. Doesn't matter what type it is. You take the data, you design an algorithm to make a decision based on the data, you test it out, and then you employ it in real life. And as you get the information in real life, you feed it back into the system, and the system repeats itself. That's an AI feedback loop. But here's the problem. If the data is wrong, or the developer makes an AI algorithm that is incorrect based on faulty assumptions in the mathematics, or if it's tested on the wrong group, or it's deployed in real life in an incorrect way, you have problems in your AI. So any one of these four steps is if something's wrong with the data, or if something's wrong with the algorithm, or the test, or the use, your AI will have major issues and it will cause you problems. Let's look at some examples. And if I look at examples and I take you now to the future in this portal, this is what I'm going to show you. In the next 2 years, AI will help businesses transform operations, but if it's not verified, banks and governments will fail. And AI can leave humans fighting to prove their identities. Here's a hidden fact that those dark forces don't want to tell you. AI has been making major mistakes when it's not checked for its accuracy. When AI has been applied to the wrong systems, it fails. So this is some real life examples. This is a real life example from Frontline News. AI was applied to a Boeing 737 MAX 8 jet, and it killed 346 people on one airplane crash and another. The AI, which was called a Maneuvering Characteristic Augmentation System, MCAS, failed. And the reason why it failed is they put this artificial intelligence to help stabilize the plane, but the artificial intelligence was supposed to be for fighter jets, not passenger jets with heavy engines, payload, and passengers. They applied the AI to the wrong system, and as a result, 2 airplane crashes killed 346 people. Self-driving cars have also had accidents. CBS News reports that Cruise had to pay $1.5 million in penalty because it accidentally drug a person underneath its car and almost killed the person. In futurism, this is a image of a car driving down the wrong side of the road. And people don't know that artificial intelligence self-driving cars, if it's not trained on the right data, it makes errors. So a lot of people don't know that self-driving cars are also trained on video game data. And if video game data has someone driving a car on the wrong side of the road, guess what? The artificial intelligence will do what is said in the training data, and it will drive a car on the wrong side of the road. You get my drift? You have to check the AI data that goes into the system to make sure it doesn't go haywire. Now, here's the hidden fact that's going to blow your mind. Do you remember the Y2K programming where people were brought in to reprogram all these computer systems so they wouldn't go crazy when the year 2000 happened? They were brought in, these were COBOL programmers. COBOL is known as Common Business Oriented Language. And the COBOL programmers are getting harder to find, and no one knows how to rewrite the code. Now, this is the issue. There's so many different systems that use COBOL. There's hardly anyone left alive that knows how to update these systems. Here's the issue. COBOL is still widely used in the banking and government sectors. It is the foundation of 43% of all banking systems and handles 3 trillion of daily commerce. COBOL makes 80% of all in-person credit card transactions possible and handles 95% of all ATM card swipes. Despite being over 60 years old, COBOL remains essential for many institutions across the entire world. So COBOL is also used within government agencies. Certain codes are used within governmental agencies, and this is another hidden fact that people do not want to tell you about. COBOL was developed in the 1950s and has become a critical component of the Social Security Administration infrastructure. That IT infrastructure maintains over 60 million lines of COBOL code, which powers its core business functions, including processing retirement and disability claims. This is the issue. The COBOL needs to be updated. There's very few people that know how to update these systems. And if any small line of this COBOL code gets altered, millions of people are affected with their retirement and disability claims. Not only that, COBOL is used within the IRS system. There's a system in the IRS called BBICS to determine who gets audited and who stays safe. Now, originally, generative AI was supposed to be verified. Now, the steps to verifying the COBOL codes to Java is actually 4 very easy steps. You take the COBOL program, you code into it generative AI. So you take the generative AI and you insert the COBOL program into it. And then the generative AI generates in step 3 an equivalent code in Java. Java is what's used on cell phones, it's used on the web, it's used on mobile platforms. It is what allows all digital mobile online transactions. So the step number 4 was crucial. The step number 4 says that humans verifies the output. Humans must verify the output. And if they don't verify the output, all haywire happens. So you're seeing on the news a lot of talk about who accesses Social Security platforms. I know you're seeing that on the news. Some companies seek to access Social Security platforms to generate new COBOL to generative AI platforms. These AI systems can be sold to worldwide financial markets if they can master this COBOL to Java type of programming. But here's the catch. If these AI algorithms go unchecked and no human verifies it, if these AI algorithms go unverified, all Americans may face AI related issues with their identities, and AI may completely destroy your identity. I'll say that again. If the AI algorithms go unchecked and not verified, all Americans may face their identity possibly being erased with artificial intelligence. Companies that verify the results of COBOL to Java are companies for you to trust and invest into regarding artificial intelligence. So there's a number of companies that do this, and I can speak with people in regarding to which companies verify the AI results. Now, AI can not only take your Social Security and disability and retirement and possibly misidentify you through that. If it's unchecked, it can also misidentify you in your facial recognition, which is a type of biometric identification. Biometric misidentification is starting to happen now. If you're wondering what are AI biometrics, it's very simple. It's math. It's math forming what we call AI templates, a map to your face, a map to your voice structure, a map to your walk, a map to your fingerprint, which is automated recognition of individuals by means of unique physical characteristics, typically for the purposes of security. So all it is mathematics put into a pattern that identifies you. There's different biometric identifiers happening with artificial intelligence. There's heart rate, there's voice print, there's facial recognition with your face, your eye color, your hair color, and even for the eye color, there's iris recognition. There's movements that are programmed into AI, how you walk, how you step, how you open your arms. You have a unique way that you move, and that is captured with artificial intelligence. Your fingerprint, if you push on and off buttons, that can capture your fingerprint. There's different biometric identifiers that's being used currently in our present day with artificial intelligence. So this is the hidden information people may not want you to know. So step 3 is where I take you into the future. We have to decide to look for ways to invest in quantum computing to help resolve issues with AI identification interfaces. So in this next part, I'm going to move and I'm going to take you with me. We together are going to move into the future, and we're going to take a look at how quantum computing is going to be the new type of technology for the future for computer processing. And we're going to see how it can help both companies as well as individuals keep their identity. In this section, we answer basic questions. What impact will quantum computing have on security, and what will the technology look like for the future? And again, I'm going to take you into the future so you get a deeper revelation of what to expect. The future tech applications of quantum computing includes military communications. Any person or entity that has the fastest communication wins wars and wins battles. That is the main reason why quantum computing is being generated. Whoever owns and capitalizes on the fastest communication possible has a military advantage. But it's also used in advanced cybersecurity technology, future hologram video technology, where you'll see people come up in 3 dimensions in your living room where you can talk to somebody in video. Nuclear fusion ignition clean energy, where somebody is using quantum computing with all the nuclear fusion data to keep clean energy in our environment. New medical treatments and drug development methods where quantum computing will be able to understand the key factors for to make for new pharmaceutical drugs to heal people faster. Stronger national security as a result. Every single nation will be interested in quantum computing for stronger national security. And there's going to be advanced aerospace engineering and space travel with this type of new technology. Now, let me share some of the quantum computing basics. Quantum computing is a multi-disciplinary field comprising of aspects of computer science, physics, and mathematics. And it utilizes quantum mechanics to solve complex problems faster than the classical computers. What would take a regular computer 5 million years to solve can take a quantum computing system 5 minutes. That is the doorway that quantum computing opens. It opens a portal for you to jump into the future and solve things at a much faster rate. The field of quantum computing includes hardware research and application development with physics. Now, quantum computers are able to solve certain types of problems faster than classical computers by an advantage and that's taken from quantum physics. Now, let me describe to you our current day computer setup versus the future computer setup. The current day computers, the computers that we are looking at Zoom with, the computers that we go to Best Buy and purchase, or Dell, or Google, or Apple, name it. Even if you use artificial intelligence with the ChatGPT, they all deal with a classical bit system. What a classical bit system is a binary system with 0 or 1s, meaning 0 is where no information lies, 1 is where information lies. And all the computer systems that are used across the entire world, even artificial intelligence, uses 0 and 1s. This is what we call the classical bit. But in the world of advanced quantum computing, we don't deal with 0s and 1s. We deal with what we call a ball, and this ball is called a qubit. And on the ring of the exterior of a ball is your data. Your data will contain 0s and 1s. And all along this ring of the ball, you can contain information. You can have data along the entire ring, and you have several rings that go around a ball. You have much more data that you can put on a qubit ball that will give you information that will process it much faster than a classical bit system. So the difference between our present day computers is that our present day computers deal with 0 and 1, and the future computers that everyone's going to use are going to deal with balls that deal with this circumference of a circle that's around the ball that carries data. Now, information in this quantum system is transferred by particles of light. Albert Einstein, through quantum entanglement, was able to see that you can attach information to light particles, and you move the light particles places and they deliver the information for you. Now, light particles move extremely fast. Dark matter can possibly move faster, but light particles are the fastest moving particles in the universe that also carry information. There's no other particle that moves faster than the particle that moves at the speed of light. And light is the only particle that can move that fast and contain information. So in quantum computing, you attach information to particles of light, and that's how you get it from one place to a next very quickly. Now, there's investments happening in quantum computing. There's been $38 billion in public funds for quantum computing technologies. This is public funds. This isn't even government funds. This is public funds for quantum technologies. And then there's 2.1 billion for that was placed into quantum technologies in 2022 alone. And it's moving so fast, rapidly moving from the lab to the commercial marketplace, that quantum investments is the future of emerging technologies. Now, I'm going to briefly describe to you how quantum computing works through 3 quantum physics aspects. And you don't have to be a physicist to understand this. I'm going to break it down to us in easy to understand terms so it makes sense. It works through 3 things: entanglement, superposition, and decoherence. So let's first look at entanglement. Albert Einstein was the person that first said that there's such thing as spooky interaction at a distance. This represented something in quantum physics called quantum entanglement. And the idea is this: if you bump 2 particles together, once they separate and they move away from one another, when they move really far, they still communicate with one another. When they originally bump into one another, they exchange information and they remember each other. So these particles exchange information once they collide, and then it doesn't matter how far these particle moves. One particle could still be on Earth and another particle could be going to Jupiter. They still can talk to each other in real time because of a physical property called quantum entanglement, which says when they exchange information, they can continuously communicate the information no matter how far these particles are away from one another. That's what makes the communication so fast in quantum computing. Next, we're going to look at superposition, and it goes back to that ball. Remember that qubit where it's that ball and it has rings on the outside of the ball and it carries data? Well, the zeros and ones is where data exists on the exterior of this ball. So you have a whole lot of data on the exterior of this ball. And so when these balls connect with a 1 and a 1, they exchange information through quantum entanglement. So if you put the balls aligned, this is a real life image of a superposition. If you align them where the particles connect, you can add the particles together. So basically, the distance of when it first collides, you can stack up the different type of hardware to create superposition. So when you add up all these locations, the information can travel quickly. That's superposition. You can add up different connections and they'll still give you the same result. That's what we call superposition. So you can interchange the location of these and they'll still add up together. Next is decoherence. Coherence time is how long can a quantum state live? So coherence is the longer information lives, the better accuracy of your data. But the problem is that if there's outside noise or vibrations, it destroys the quality of your data. So what you may originally start off with $1 million, after it goes through the system, if there's no noise cancellation process, $1 million can turn into 1 penny simply because they relayed the information wrong. So in order to understand decoherence is breaking down any exterior factors of noise or vibration or heat that could cause the information not to be transferred accurately. So in this picture here is an exterior of a quantum computing machine where the exterior cancels out outside noise. So it is better accuracy with the information that gets transported in the entanglement and the superposition so the information gets to where it needs to go on time and fast. And the accuracy of it remains intact. So the quantum computing is trying to master how to keep the information intact so it can share information long distances. So I'm going to take you into the future. We have to observe the needs of people and companies in the future and invest in solutions with quantum computing. In doing so, you create a better future in advance. So we have to look for quantum computing ways that can help companies and humans secure their identities, data, and assets. We have to help companies and humans secure their identities, their data, and assets. Okay. I'm going to break this down for us so we really understand this. There's biometric hacking risks. There is a gap. Remember how the banks are dealing with COBOL and they're trying to make sense of that system? Well, banks right now are using artificial intelligence and they're also using something called voice prints. Like, for example, Fidelity has a voice print processing system where you can call up and something identifies you through your voice. So there's a voice print out there of you. But here's the problem. That can be hacked. And because there is a gap between COBOL and there's a gap between Java, where all the artificial intelligence lies with all its programming, because there's a gap between COBOL and a gap between Java, hackers can easily infiltrate that gap and take your identity through biometrics. So here's how I take you into the future. In the next 24 months, companies may have their customers' biometric data hacked. Voice print ID technology at banks will be hacked. Digital fingerprint captures at schools to hire teachers can be hacked. Facial recognition ID from grocery stores, self-checkout lines, and global airport scanners also can be hacked. And patient photo IDs from hospitals are already being hacked. So this is how the biometric templates fail. And this includes hacking. Take a look at this. There's what we call deep biometric attacks, deep fake biometric attacks. Synthetic fingerprints, synthetic faces, and irises can be used to fool biometric sensors, and it also can be fooled to create these screens on Zoom where someone can pretend they're you and get multi-millions of dollars because they think that you've authorized it and it's been a biometric hacking. The second is a biometric template can be reverse engineered. All the data that comes from biometrics is stored someplace, and there's templates, which is a mathematical map that's based on your information. But there's what we call reverse engineering, where someone can go through and reverse the mapping and get your original data. It's happening already. So that is how somebody can hack your biometrics. And unlike biometrics, unlike your PIN code, where you can change it, biometrics is something in which once it's out there, you can't get it back. And the third way is failure to correctly capture or enroll data. Some individuals may be unable to create a usable biometric template due to physical conditions. For example, if there's poor lighting and a poor camera that's being used to catch a facial recognition, your facial recognition may be distorted, and then somebody may think you are somebody that you're not, and then you have a knock on your door where somebody's saying that you committed a crime, and that wasn't you. That's one way that failure to capture or enroll biometrics is currently affecting people. So if we look into the future, systems will be hacked. Protections are needed to help people get their identities back using quantum computing. This is how quantum computing can help. So in the future, we're going to look for investment opportunities for companies that employ quantum computing technology to do two things: protect organizations that use generative AI to translate COBOL to Java reprogramming, like the banks and governmental institutions. And then two, protect humans who have had their biometrics hacked, who need to reclaim their identities. There has to be some sort of way for someone to prove who they are when there's been some sort of biometric misidentification. And that's where quantum computing is going to come into effect. And there's companies that are being generated that to answer these questions. So we want to look for companies that find ways to apply quantum computing that can, and here's one example, capture human AI biometrics on worn replaceable devices without the use of surgical chip implants. You want to find companies that are creating AI biometric worn devices so people can identify themselves through the device and not through a faulty computer system that may misidentify them through biometrics. And then you want to invest in companies that keep satellite data secure with quantum computing, where the information being downloaded and uploaded to servers are protected using quantum computing. And third, you want to relay banking data directly to customers through quantum ID technologies, where they don't have to go through a third chain. They go straight to the person from a satellite, where the middleman of potential hacking can be removed. So these are the ways in which you can particularly invest in quantum computing in the future. And the future is coming up really quick. So there's a major opportunity in front of you. You are at a portal. New steps about the future will allow you to walk through your door. And with these 3 steps, you walk into your own portal. And this portal is obtained, and you get to this portal by taking the steps of understanding how to make decisions from the future, how understanding the future of biometrics risks with AI, and understanding the future benefits of quantum computing. When you take these steps, you walk into your portal and you go to a higher dimension with your business, with your life, with your investments, with your overall strategy. And with these 3 steps, you can do absolutely anything. And in my case, you can do anything that you envision in the future, even become a rocket scientist. I hope that you have enjoyed this presentation. I am Olympia LaPointe, author of the Answers Unleashed book series, and I am the founder of the Quantum Deciding AI Biometric ID technology. What you want to do is, if you have any questions, you're welcome to contact me directly at my website and email below and call our office for more information. And you can follow me on social media. You can check out my books on answersunleashed.com/books or olympialapointe.com/books and check out any one of the books here. And you can follow me on social media on Facebook and Instagram at Olympia LaPointe, YouTube at Answers Unleashed, and LinkedIn at Olympia LaPointe. I hope you have enjoyed this presentation, and I will see you next time.